well, because it would be a bit awkward if René would be moderating his own talk. Just for in case there would be newcomers, I think everybody knows René, but yeah, I'll just shortly present you, René, because we would have some new audience. So you are Professor Resilience Resource Supply at Leiden University, and you're also the head of the Department in Industrial Ecology at the Center for Environmental Sciences, and chair of the theme Circular Industries in the Leiden-Delft-Erasmus Center for Sustainability. It's always a mouthful. And actually, you initiated these talks a few years ago. I think it was 3 or 4 years ago. It was called Future Resources at the time, and was mostly dedicated for people in the CML, so the Center for Environmental Sciences. And we're expanding these talks to 3 universities and beyond, because we also have some external organizations joining. So it's very nice. We now have, I think, a mailing list of above the 100 people. Doesn't mean that everybody joins each time, because the topics vary a lot, but so it's very nice. Very proud of that. And actually, this talks also marks the end of you moderating them, because you are stepping out your function as chair of the Circular Industries team at CFS. And your position is going to be taken over by Ruud Balkenende, professor at TU Delft, Industrial Design Engineering. Ruud, you're also there today. Thanks for joining. And Ruud will be moderating the talks as from September, because this is also the last talk of this academic year. René, the floor is yours.
Yeah, thank you so much, Elise, for your nice introduction. And I should also thank you for after initiating something like this, it also has to be professionalized. And that is something that you did very well. And I think that that's also a reason why we have now maybe an audience of about 100 people. And also very nice to have all this, basically stored in a YouTube channel so that everybody can still have a look at it, even if they don't join during the live meeting. So thanks for that, Elise. And also, thanks for to Ruud for joining also today, and also for taking over this role. I think I thoroughly enjoyed it, so I hope you will too, Ruud, and I'm sure you will.
I'm convinced I will.
Yeah, okay, and I'm sure you will put your own signature on it. Let's say. Today I'd like to go through some of the topics that have been discussed during some of these meetings, and also a bit of the broader topic, also why we actually are talking about this so much at this moment. So the title of my talk is Critical Materials, the Energy Transition and Geopolitics, a complex mix. That it's very much related to also the title of the white paper that we produced within this LDE hub. And I think it's a topic that is very much on the political agenda. If I look at the number of invitations I get for talks in all kinds of fora to discuss these types of things, it has been increasing quite rapidly the last couple of years. So this is clearly a topic that is on the minds of people, and it has to do with to a large extent also the political situation that has changed a lot. COVID has shown us that we are very much dependent on supply chains, that we are not able to produce everything in the Netherlands, not everything in Europe even, and that we are very much dependent on international supply chains for all kinds of materials, products, etc. So that the world is actually very much interlinked if it comes to supply chains of all kinds of critical goods, important technologies, etc. And that in a world that is also changing towards more protectionistic type of policies. You can see that with the Inflation Reduction Act in the US, but actually it was already started by the Made in China 2025 policy that was introduced in China in 2019. And also now followed up by the Critical Raw Material Act in the EU, and also the Net Zero Industry Act. All those acts are basically, you could argue, protectionistic type of policies, and that is kind of interesting because, like I said, at the same time we live in a world where globalization has brought us a lot of progress in terms of economic progress. Of course, there are always also side effects in terms of environmental and social impacts, but it has brought a lot of wealth also to the world as a whole. So globalization has served as well as a global economy, I'd argue. And at the same time, now you see that, well, with all these protectionistic measures, it's not very clear how that will work out in terms of all these different supply chains. You can also see that governments are quite opportunistic if it comes to these types of things. So they tend to still import things that are very important to them, even if the countries that this stuff comes from are not the most friendly or not the ones that you want to deal with so much. But yeah, just from an economic opportunistic type of perspective, you can still see that this trade is going on. So we're entering a different era with less focus on globalization, more focus on protectionism for local economies and national economies. And well, that's what I want to discuss about today, and then focused on the energy transition. So it's clear that for the energy transition, we really need a lot of materials, not only for the solar cells and the wind turbines, but also, of course, for the electric vehicles and for the electricity grid. Those grids have to be improved and strengthened, and they have to grow a lot in the coming decades in order to make it possible to basically connect supply and demand much better and to align it much better. And that is especially important in a world where solar and wind energy are important energy sources, because, of course, the intermittency of these sources makes it so that you have to have a lot of interconnections. And also, well, the distributed nature of these energy sources also makes it quite different from centralized power plants all over the world. So we need a lot more materials to build all this stuff. The International Energy Agency, they produced a report in 2021, first addressing this issue. The first time that the International Energy Agency was looking at materials. They recently updated their report, so we'll be showing some figures also from that later report. But I think this is still an interesting graph, even if it is from the 2021 report, because it clearly shows you that if you go to the left side of this graph, you can see that EV and battery storage. So batteries are crucially important if it comes to this material demand. And that has to do with the fact that batteries are very material intensive. At the moment, the dominant technology uses a lot of lithium, nickel, cobalt, manganese. And yeah, you need a lot of them. I mean, there are many cars. The prediction is that we will have 2 billion cars on the road in 2050. So if all of them have a 60 kilowatt hour battery, that means a lot of materials need to be invested in these batteries. So that is important to understand, that these batteries are crucially important. Yes, we need a lot of materials for the solar cells and the wind turbines, but these batteries are really crucial. And also, of course, if you look at an electric car and you compare it to a conventional car, then it's also clear that because of this battery, but also because of the motors that you use, the electromotors that often contain rare earth elements in the form of magnets, you need quite a few of these critical raw materials or strategic raw materials like copper. Much more so than in a conventional car that is based on the burning of the combustion of fossil fuels. And at the same time, of course, we know that EV sales, and this is a graph from the global EV outlook from the IEA, I should say. We can also see that electric car sales are growing rapidly. We are in a bit of an S-curve. I think there's a little slowdown now, so you can see that not all policies are implemented as fast as they were planned at the beginning, but still, it's clear that also in the further future, this demand will go up, and that also means an increasing battery demand. We can already see that in this graph where the EV batteries are shown first, let's say, divided over different types of vehicles. Light duty vehicles are basically regular cars. And then buses, trucks, and storage, but regular cars, of course, dominant here. Then if you look at where is this demand coming from geographically, then you can see China is a clear leader. The fact that we are importing a lot of Chinese EVs is not just because these EVs are nice to have, and they're becoming better and better and competitive with European and American brands, but also because China has a huge internal market for these battery electric vehicles. That's also a clear government policy in China, also to improve local air quality, and also, of course, economically. Because they didn't have a lot to gain to invest in internal combustion engine cars, because well, that market was already basically taken by the European and American producers. So they saw really an opportunity to jump over that technology and directly go into EVs, because they already saw that this would be the future. So that's also why China is quite dominant also in the demand of these vehicles. If you look in the further future, you can see that this will be growing even further. You see different scenarios here: the STEP scenarios, the APS scenario, the net zero emission scenario. But basically, if you look at 2050, you can see that there's a huge increase in EV sales compared to the 2023 level. And if you look at the percentages, then you can see in the net zero emission scenario, the total percentage of sales, let's say, would be about 100% or a little bit less than 100% in 2050. So basically, every car that will be sold in the world would be an electric vehicle. And if you go to these other scenarios, like stated policies, then it's a bit less, and it can be something like 70 or 60%. But still, it's a significant part of that. It is also clear that if you want to create all these electric vehicles, you need a lot of lithium, nickel, cobalt, graphite, and rare earths for the motors and the other materials for the battery, basically. And also copper is also required, not only for the cars and the batteries, etc., but also, of course, for the grid and all the other things that you need copper for. If you switch to electricity as the main energy source being produced, then copper is crucially important, logically, because it is one of the best conductors that we have in that system. What is also interesting to see from this graph is that you can also see that clean energy use, although it is quite important and it is also growing, for example, for lithium, you can see it's growing quite clearly. You can also see that there are quite some other uses. And for copper, for example, clean energy is not the only requirement. I mean, construction is crucially important for copper, for example. And also you can see for rare earths, graphite, and cobalt, you can also see that clean energy is not the main use, let's say. And that will change over time. It will become more and more important the more we use these clean energy technologies. But it is at the moment, there's also a lot of other use. It's also clear if you look at the plans for the future. This is a graph of the planned wind parks, and you can see that, well, a few of them are already built, but all the gray ones are basically the ones that still need to be built. So you can also see there will be a huge increase in the demand for wind turbines and all the materials related to that. And like I said, it's also the grid itself. So this is an example of a high voltage direct current line that has been built in China, more than 3,000 kilometers long, overhead, and 12 gigawatts of power going, let's say, from the west of the country, where there's a lot of wind and solar power production, to the east of the country, where most of that is actually being used. And here you see a picture of it crossing the Yangtze River. Huge projects. Everything is bigger. We used to say everything's bigger in the US. Nowadays we say everything is bigger in China. For that, of course, you need. Let's go to this one. It's also clear that the energy transition is basically a material transition, and a material transition from fossil fuels to metals, and with that it can basically be a transition to a circular economy. Fossil fuels you burn and they're gone. And metals, in principle, you can recycle them endlessly, although, of course, it will cost energy and you will lose some of the material in the process. But it's very different from just burning fossil fuels. So we also go from a system that is really focused on securing the continuous inflow of fossil fuels to basically fostering a large stock of metals in society in the form of these electric vehicles, solar cells, wind turbines, etc. Then if it comes to the geopolitics, well, it's clear that both the COVID crisis and also the Russian aggression in Ukraine has shown us that the world is quite vulnerable if it comes to the supply chains. Yeah, we were suddenly confronted with the fact that there was no natural gas anymore coming from Russia. So Europe had to basically change their energy supply to a large extent, quite drastically in a very short time period. We succeeded in doing that, but it really showed that it might not be a very good idea to be so dependent on one individual supplier of something as crucial as natural gas in this case. And therefore, you can see all this, these policies now also popping up in Europe, but also in other places in the world. But then, of course, you have to realize that, yeah, although we might want to be less dependent on individual countries, you can still see that, for example, if it comes to EV battery production, that China is quite dominant. All the red blocks in this graph are Chinese producers, CATL, Build Your Dreams, and other producers, and the blue ones are Korean companies, and the gold one is a Japanese company, Panasonic. But you can see the dominance of China also in the production of these batteries, and even some of the larger plants that will be built in Europe are Chinese owned, basically. And that also, yeah, you can also see it by in this graph. It's a bit of a difference. It shows it a bit differently, but it's basically the same picture. Then, if you look at this dominance in the supply chains, it's often has a focus on where the materials are actually mined. But actually, if you look closer, then you can see the further you go into the supply chain, the more dominant China becomes, from mining to material processing to cell components to battery cells and EVs. You can see that, well, especially in battery cells and also in cell components, China is completely dominant. And the mining takes place in many other countries in the world, like, for example, cobalt is largely mined in the DRC in Africa, but it's largely processed in China. So China has a very important role to play here. And also, something to keep in mind is that if it comes to the cost of the materials, compared to the cost of the product, then, for example, in solar cells, the cost of the materials are not very important, but in a battery cell, it is crucially important because there's so much material in the battery, and 51% of the total price of the battery cell is currently the cathode, in which there is this nickel, cobalt, and manganese. If you look at the solar panel supply chain, then you can see also the dominance of China, not only in the polysilicon production, but also in the wafers, the cells, and even in the modules. If you look at the modules, then some of that has been transferred to neighboring countries simply to avoid also import tariffs that are used in the US. So that's why some of this production has gone to neighboring countries to avoid paying that kind of import tariffs. But China is really dominant in this supply chain. I want to move to this. Oh, it takes a bit of time. If you look at lithium, for example, you can see that production is also quite well distributed over the globe. So there's a lot of production in Australia at the moment, and that's where most lithium comes from, rock mines. But of course, there's also a lot of lithium in the salt lakes in South America. But if you look at, let's say, to the potential production, so if it comes to do we have enough of this lithium available, then you can see there are many places where you can actually mine lithium. It's not a scarce material in that sense. So, and mining can be scaled up for lithium relatively quickly. We've seen that in Australia, new mines being opened within 5 years. So it's also important to keep in mind that yeah, it's sometimes it's problematic to scale up production, but at the same time also there's lots of potential mining available. So we're not running out of materials. Is basically what I'm trying to say here. If it comes to cobalt, you can see here it's a result of one of our PhD students, where you can see indeed these flows moving, let's say, from the DRC to China for being transferred into battery grade materials and batteries itself. So these types of figures and these types of analysis helps you to understand how these flows actually work. And if you go one step deeper, then this is, for example, for lithium again, you can see that, yes, there's a lot of mines in Australia, there's a lot of mines in Chile. But then if you look at which companies are actually mining there and who are the owners, then you can see in the middle part, for example, yeah, China is quite important there in the ownership of some of these companies, but also the US and Canada and Chile are quite important. So in this types of analysis, you can also get better insight in which companies and which countries actually control these supply chains. It's also important to know that supply chains are relatively fragile. If you want to get materials out of the copper belt in Africa, you have to go through all kinds of small roads towards the ports, the different ports that you have in the southern part of Africa. And that's often very problematic, old infrastructure, dangerous, etc. But also, yeah, just accidents can happen, like here, the blockage of the Suez Canal that was at a certain moment just disturbing global supply chains. So in that sense, supply chains are also quite problematic. And fragile, you could argue. Another important topic is responsible sourcing. We don't just want to have a lot of materials, but we also want to have it responsibly sourced. So we're now talking about digital product passports, about certification of raw materials. And therefore, yeah, you need also traceability. So you need to know where your materials actually come from. So there are a lot of projects on the European scale now going on, like the Maritrace project, which we're also involved in, which is really looking at, so how can you trace these materials back to through their supply chain, and how can we make sure that it comes from responsible sources. And then, well, an important subtopic there is artisanal small-scale mining. It's often stated that we should have this standardization, but if you have these standards, it's very difficult for artisanal small-scale miners to comply to those. And that means basically that you're taking away a means of living from 200 million people that are dependent on artisanal small-scale mining. So this is something to take into account once you start talking about certification, etc. Another thing that has been popping up quite a bit is deep sea mining, and I've been talking about that in several lectures and also debates recently, because it's coming closer and closer. It might be so that within a year or so we might actually see commercial deep sea mining started by the metals company in the Clarion-Clipperton belt in the Pacific. And it's often said that, well, we actually need that in order to make the transition happen, the energy transition happen. And that's just not true for a couple of reasons. First reason is that there's plenty of resources on land. Second reason is that, or maybe the first reason you could argue, we can also be very clever in our technology choices and which materials we actually use for different products. How we treat these materials. We can also start by other circular strategies by just making sure that we don't need as much as materials as we now think that we do. And the third reason is actually that the scale, well, the rate at which this will happen, so the scale up at this will happen is insignificant if you compare it to, let's say, all the mining that is going on land. So even if you would start doing this, it would be well, maybe 1% or maybe a couple of percent from of the total world production, but it would not really make any difference, to be honest. So you could just as well say, well, just let that deep sea be because of all kinds of ecological effects we don't really know of. But there's certainly not a reason to start using these deep sea mines in that sense. Yeah, and then I'd like to go over to these circular strategies. I think that is crucially important, that we make sure that we don't just think about these materials as we need them because current technologies need them, but also think about, okay, so if you have more public transport, of course, you need much less cars. If you have shared cars, then you need less cars. And if you organize recycling very well, then in the end, you can make this whole system to a large extent very circular. And one important aspect of that is the choice of materials for batteries. I've shown you already that batteries are crucially important in the total material demand. But you can also see that in this graph, for example, that lithium iron phosphate batteries are now already 40% of the world market. And lithium iron phosphate batteries don't contain manganese, no cobalt, no nickel, just lithium iron and phosphate, and of course copper for the let's say the electronics part of it. But you don't need these raw materials. And like I said, with the deep sea mining, these manganese nodules that are then mined contain a lot of manganese, of course, manganese nodules, but also nickel, copper, and those are and also copper actually. So actually, yeah, so these materials are crucially important for current NMC technologies, but if you look at these LFP technologies, you don't really need a lot of those materials. So this is purely also a technological choice. LFP batteries have other advantages. They last longer, they have more cycles, they don't degrade as fast, lower fire risk. The only thing is that it has a little bit lower energy content. But there's a lot of cars already on the market. The regular range Teslas, for example, contain LFP batteries, and as far as I know, they're doing quite fine. So a lot of this stuff has to do with the choices that we make. I won't go into these details. What I do want to show is finally a couple of slides on battery and battery design and battery recycling. This is a battery stack from the Tesla Model Y. What you basically see is how these batteries are an integral part of the design of the product, and which makes recycling and reuse at least quite difficult. It's very hard also to get the individual cells out. And that makes the reuse of these battery packs very problematic. Of course, you can shredder the batteries and take the materials out, but any type of second use might be problematic. And then, for EV motors, you have these magnets with rare earths that are in different configurations in these rotors. And if you want to make them recyclable, you should be able to get them out. And that is not straightforward, let's say. So the design of the rotor can also help a lot with regards to the recycling of this stuff. Now, my final slide. So I'd argue that the future of energy is actually circular. So we are moving away from this securing of continuous inflow to a fostering of a standing stock of metals in solar cells, wind turbines, supergrids, and batteries. And that requires a complete shift of mindset if it comes to the energy system and what is important there. And we will build this stock in the next 30 years if we want to comply to the climate goals. And even if we don't completely comply to it, it might take 40 years, but still we will build it. And this requires a temporary fast scale-up of mining of these material. But what is also important to note is in a recent article we published, we also show that actually mining in total, so the amount of stuff that we get from mines will actually go down, and it will go down immediately if you have an energy transition because you need less coal, oil, and gas. So yes, we need a lot more metals in the near future. So this type of mining should be scaled up. But in the end, we will end up in a system with way less mining than that we have in our current fossil fuel based system. That was my final slide. So thanks for your attention.
Thank you, René. very interesting presentation. And I think we already have a question in the chat, but maybe Friedrich, you would like to ask the question directly to René?
Yes, all right. So thank you, and sorry for popping in a bit late, so maybe I've missed it. So on the potential demand for manganese, I was startled and shocked to learn that today in battery recycling we landfill the manganese oxide because we can't get rid of it. Have you heard of that? And what's your take on that?
Yeah, I think that's one of those problems you have when you start up recycling and there's cheap raw materials on the market, because basically what you see often in circular economy is that there's no business case for the secondary materials. Well, in my view, that simply means that we have to create that business model and have to force it. And you can do that with government measures by, for example, requiring recycled content in new batteries. That will create a market immediately. It has been done in other sectors as well, and it will work. And of course, you have to tweak those policies in such a way that it actually works, because there's always trade-offs and there's always, well, loopholes, let's say, that make it problematic. But I think that is the way to go, because I think will be very problematic for some of these materials to actually have a business case for recycling, because the manganese is still worth something, and for the nickel and the cobalt, it's clear that's and the copper also, that is extracted because there's a business case for it. But if you go to lithium iron phosphate batteries, for example, well, the iron is not really worth well, that's worth a bit, but there's no the business model for recycling batteries will be way worse, because the only thing that you can extract from it is the copper that is in there, and maybe some of the iron, and maybe some of the aluminum that is used to or steel actually that is used for making the cells. But the business case will be much less than for nickel, cobalt, manganese batteries. So in those cases, the only thing that you can do, I think, is as a government, is make sure that you have these regulations in place that make recycling mandatory. Yeah.
Thanks.
Yeah.
Sorry, I was muted. Peter, you have a question as well.
Yes, René, thank you for the nice presentation, overview of all trends and happening. My question is what we can do or expect on concrete projects addressing this. What is within our reach of Dutch technology? We have circular circuits that clearly addresses some of these challenges by retrieving the materials from circuits and to give direction how the circuit should be constructed for good recovery in future. What other initiatives are within reach? What do we have as Dutch science and industry? What do you think are also government supported projects for coming years?
Yeah, that's an excellent question. Thanks for that, Peter. And it is a topic that we have been discussing in a small group of people that were working on a growth fund proposal with regards to critical raw materials. So, and since these growth funds are really focused on the Netherlands, so the question then immediately pops up, of course. So, okay, so what is it then that we as the Netherlands can actually do? Because this is clearly a global issue. Many of the things that we are talking about should be arranged on a European level. So, okay, so what is our role then? So, and then the focus should, of course, be, I think, in my view at least, the focus should be on what is it that we are, what are our unique selling points, what are the things that we are good at in the Netherlands within the European context. And of course, then a couple of things pop up. First of all, we are very important if it comes to the distribution and of goods. So think about the Rotterdam Harbor area, which is crucially important if it comes to the the distribution of fossil fuels and carbon-based energy sources and also material sources, and that would have to shift towards metals. And then you can think about, okay, should we have refineries in the Rotterdam harbor area that replace, let's say, the fossil fuel refineries, but then have, let's say, metal refineries? Well, that is also problematic, because for these refineries you need a lot of energy, cheap energy, because you have to compete with other places in the world where energy is a lot cheaper than in Europe. You can think about recycling plants, because we do end up with all these materials in our society. So we end up with all these batteries, all these solar cells and wind turbines in our society. So we have to take care of that within Europe. And if it comes to offshore wind, then it's also clear that Rotterdam can play a crucial role there, because of the location that they have and the type of room they have available. But that's just one part of, let's say, the recycling part of the whole story. I think a very important part of the story lies in the design of the systems that we work with, the design of the products that we use. And that is something that the Netherlands have been known for. I think we are quite well known for being creative there and being innovative there. So I think that is also one important part of the puzzle. Can we actually design products that are made in such a way that they last longer, that they can be repaired, that we don't need as much materials as we think we do? So we have a lot of good material science in the Netherlands, for example, that is working on, let's say, for example, the getting rid of alloying elements in steel production. So all these types of things are important, I think. And then a third part is the policy part. Like I was just discussing, if you want recycling to work in a world where basically raw materials are dirt cheap, we are always talking about high prices for copper, etc. But copper, that is one of those elements that is relatively expensive and for which recycling makes sense. But for a lot of other materials, from an economic perspective, the primary materials are just way too cheap. So we have to think about policies that will make this work. And that is also something that I think in a country like the Netherlands that we can really work on. So which policies do work and which policies wouldn't work. So that's the type of thing that I think we should be working on.
Thank you for your answer. Indeed, on the critical raw materials, there is plenty of interest, but it's not clear how that has to be solved due to these aspects.
I'm not. What is the question then exactly?
No, not it was not a question.
Oh, sorry.
You say policy. We see policy in critical raw materials. Maybe the question is what initiatives can come out of this policy. It is supported that we get less dependent on critical raw materials, but how? And what?
So indeed, how is a good question. And one other thing that you can focus on is, well, what materials do we already have? Because we also know there are big metal smelters in the Netherlands, but also in other European countries. And they have the potential also to extract other critical raw materials from the sources that they already have. But the thing is, of course, that we should create a business model for that. Because if there would be a business model already, then it would already have been done. So we have to think about how can we make better use of the materials that we already have in our system. Yeah.
And that has to start with the business model and the perspective there. Yes, thank you.
In the end, yes. Yeah.
Yes, thank you. Well, first of all, thanks a lot for the very informative presentation. To add perhaps a little bit to the point of Torsten, I think that with manganese, probably there are far better results with hydrometallurgical recycling processes compared to pyrometallurgical processes. So I think that we, at least in Europe, should ramp up the hydrometallurgical refineries. But then still, it's possible from a technical point of view, and I think that it adds to your point, René, that probably it's not financially attractive, and that we need to keep that into account. So actually, also during your presentation, a news item that I read last week popped up into my mind, and that's that with the Inflation Reduction Act, that there is a Tesla model that where the normal range Tesla with LFP batteries is not applicable under the Inflation Reduction Act, so they won't get the $7,500 reduction or subsidy. Well, the long range version with the NMC batteries does get it. So that really nearly compares the whole price differences. So I think that the long range is only $1,000 more expensive than the normal range. So is that a good strategy out of reducing your strategic now I can't get the word, your strategic dependence on certain countries, or
Yeah, that's a very nice point that you make, Luke, and I think it's a nice example of that's why I said, well, if you want to test these policies, then there are always, let's say, these loopholes or these things that you think, oh, but that was not my idea. So it's important to note that beforehand, and when you design these policies, because the Inflation Reduction Act is very clear. It's very so OEMs know exactly what they need to do in order to get these funds, but at the same time, it's also very rough to that respect. And of course, the reason that the LFP batteries don't get this refund is that LFP batteries are completely dominated. The production of that is completely dominated by China. So these batteries will come from China, and that's why they wouldn't get this compensation. And while NMC batteries can and are made in the US, and even the raw materials can come from neighboring or friendly countries, let's say, to the US. So yes, these kind of quirks that occur by policies. Yeah, of course, I think from a critical raw material demand perspective, LFP batteries are way better than NMC batteries. So I'm also very surprised. You can also see that in Europe, actually. All the battery plants, the giga plants that are being built at the moment are all NMC plants. And again, the same reason I think is that well, China is simply dominating the LFP technology. But like I said, 40% of the market is LFP, and that is because China is a huge market, and because of safety regulations. That's one of the reasons why China chose to go for LFP. The fire risk is way less than for an NMC battery, and that in crowded cities in China, you can imagine that's also an important topic. So yeah, what's my answer then? My answer is my answer is yes, you're completely right. It's not a very good idea to make sure that you use NMC batteries instead of LFP batteries, but yeah, sometimes these policies work that way. Yeah.
Yeah, I still have mixed feelings. Is it ridiculous because you are promoting NMC battery electric vehicles, or is it a genius step because it really incentivizes also creating or ramping up LFP production in your own country? So.
Yeah, it's a bit of both, I guess, in that sense. Yeah. Yeah.
So you did. I think Ruud was next. You are still muted. I don't know if you're talking because you're very small on my screen.
I'm still muted, but no more. Some additional thoughts on what you remarked about the importance of design, and there I couldn't agree more. But you also showed the example of the Tesla battery that is basically built in such a way that it is completely impossible to recycle, although it probably has quite some advantages in thermal management during operation. So there you already have some trade-offs that you have to deal with in design. But anyhow, I think in the end, it is also about the policies that you need to implement those design changes, because we can quite easily think about a number of changes in designs that would make recycling or reuse, refurbishment far easier. But there is not really an incentive to do so, and certainly not for companies from outside the European Union. So policy, and I think that's also something you illustrated in the first half of your presentation, especially geopolitics also plays an important role. And don't we see here that geopolitics actually is far more important, aiming at supply security short term, than the perspective of a circular economy, which is on a longer term. Also, for the energy transition, we need to open many new mines. We need additional stock. But by opening those mines, of course, we also create an infrastructure that has the incentive to keep going. So how do we already build in that this is peaking, should be peaking, and be taken over by recycling and other ways of lifetime extension on the longer term? So I'm not sure if this is a question and if you can answer it, but basically, in setting up policies, we see a number of trends that do not really facilitate going to more circular strategies. And how might we be able to make changes there and at this term?
Yeah. Yeah, I think it's a very good point that you make, Ruud, and it's a very difficult one indeed. I don't have a clear answer to that, to be honest. But you're completely right that the whole geopolitical type of wave that is now going across the world economy is something that is, well, that is seen as very important by strong governments like China, like the US, but also in Europe nowadays. So that is something. So the security of supply, strategic autonomy will be things that we will have to work with in the next decades or so, I'm afraid. And then, but then that could also be then that, of course, a part of strategic autonomy is that if you can keep the metals that you already have in your society, you already have a secure inflow of materials. What you see at the moment actually is that a lot of these materials are the waste products of these materials are being exported again to China. Because China is willing to pay the highest price on the market, and they have the recycling technologies in place to make that actually happen. So if you're going in that direction, it's completely opposite to what we want with strategic autonomy. So that is something that we have to take care of, and something that we have to deal with. If we are then thinking about strategic autonomy, don't only think about primary materials, but also think about secondary materials. I think that is one answer.
And think about production and local production.
Yeah, indeed.
Because then also through design you can far easier enforce changes in products that also enable secondary materials to a larger extent.
And I think also Europe has shown already that Europe is one of those places that actually can also have quite strict policies if it comes to products. We have seen that with small examples like the charges, etc. But I think that we should have much more in that direction as well, standardization of certain things, but also making choices in maybe in types of batteries that we allow, etc., or things like that. So in that sense, I think there's also a lot of policies to be that can be made, and Europe is a very important market for many of these producers. So I think we can use our market power there. Yeah.
So in design, we usually try to influence the behavior of consumers, to influence the way in which companies do things. Shouldn't we far more focus on influencing governments on the way in which they set up regulations?
I certainly think so. Yeah. Because I think it's also not really fair to dump this on the consumers and it's the choices that you make. Yeah, but that is because all the regulations make it so that primary raw materials are dirt cheap, and recycling and reuse is very expensive. I mean, that's the way in which we have designed our tax system, and with value-added tax and labor tax, etc., like that, and no tax on primary raw materials. So then you get a system like this. Yeah.
Thanks, René.
Yeah.
And Sonia, you also had a question.
Yeah, and it actually ties into what René just said, because you were saying, of course, that we're dependent on materials for China for materials. However, if in the future in the EU we are recycling our own materials, then potentially these would be in our hands. But then, from a circular economy perspective, of course, there's a growing the products as a service is one of the key elements in that. Have you then given any thought if China, several Chinese companies like Link & Co. Are offering their cars as a service or as a lease, and that would mean that they actually still maintain ownership of those materials and could directly ship them back to China again. Have you given that any thought or consideration?
Yes, I guess you're right there. That once it is a lease, indeed, you're not the owner of the materials itself. So that could indeed work. I think it's a if you look at leasing in cars, of course, you're very used to that, but mostly in let's say a company context, although private lease is also growing recently. But I still think it's probably still a small part of the market, right? So in that sense, I'm not sure it will make a big difference.
But I think in the future, I mean, if you look at Link & Co., they're offering I believe it was Link & Co., their battery to swap batteries rather than charge their batteries.
So you have indeed one of these Chinese companies is indeed very much into swapping the batteries. They also do it for trucks actually, and they can also do it for private cars. I think that's a thing in China, but not so much yet. NIO is actually doing that. I was thinking about that.
You're right. NIO. Link & Co. was they were. They had another.
It's actually quite interesting. You can find some nice YouTube videos about batteries being swapped in regular cars and trucks. So it's a nice system. I don't think it's very popular in Europe, for example, and probably also not in the US. But in China, it's done indeed, and it might be even more worthwhile for trucks actually than for and also for small. Let's say delivery trucks and things like that. It might be very interesting because they can keep on running all the time there. Yeah. But indeed, you're not the owner of the battery. Yeah.
Any more questions? I see also actually on the chat a question about an article that you mentioned, René, about less mining. The question's from Martin, and he asks, is this energy transition require less mining than the current fossil system? I think it's a question for the article that you mentioned, the reference. You are muted, René.
I'm not sure what the question is, but that
I'm wondering if the question is about the title or the reference to this article.
Oh, I can
it's
send
how I understand it, at least. Yeah,
I will send the reference. Yeah.
Oh, okay.
Yeah.
Well, if there is he found the article. If there are no questions left, I think we can give a big thank you to René for his presentation and his role in the talks. And I wish you all a very good sunny day. Thank you, René.
Thank you. Thank you all.